Today we're going to have an electrical circuit recap. So let's start off with a switch. Now this is what a switch looks like when it's open. There's a gap between it, so the electrons cannot flow, current does not flow. But a closed switch, the bridge is sort of closed and the electrons can flow, so the current can flow. So that's where this idea of making and breaking a circuit comes from. When the switch is open, you've broken the circuit, but when it's closed, you've made the circuit essentially, because current can flow and electricity can flow. Okay, now let's move on to these symbols. But before we explain these symbols, we need to know Ohm's law. What Ohm's law is it's the law that relates voltage, current and resistance together. If you y equals mx plus c at this, you get that the gradient is r, knowing that the y is v and the I is x, then m slash r slash the gradient is the resistance. So this is kind of a GCSE kind of question where you'd be given a graph and then it will say what is the resistance, and to work out the resistance you work out the gradient of the graph. Okay, so let's move on to the symbols that go along with this equation. V, the voltmeter. What this does is it measures voltage. It's just a circle with a big V in it, and the wires go out the sides. An ammeter, which measures current, is a big capital A with a circle around it, and then the wires out either side. A resistor is a rectangle with just wires out on the side. So yeah, they're kind of important to remember. Let's move on to some funky symbols. These are like typical questions that are asked, like draw this symbol, what is this, that type of thing. So let's start off with a diode. A diode is like a stop-start symbol with a circle around it and the wire going through the whole thing. An LDR resistor, so we know that we're going to have to draw a resistor, is done by this, where it's the resistor with a circle around it and then the arrows coming in for the light dependent part of it. An LED, which is a light emitting diode, has the arrows leaving it because it's emitting the light. Here it's depending on the light, here it's emitting the light. And again, because it's a diode, you draw the start-stop with a line going through it. Then you have a thermistor. A thermistor sort of looks like a resistor, but it's got this line through it and then it kind of saturates. I'm going to talk more about this over here. And then we got a variable resistor. Variable resistor, again like a resistor but with an arrow through it, representing that you can change the resistance. And you got a lamp, which is just a cross with a circle around it. Don't know why that is, but it just is. Then you got a fuse, which has got a line through it and a rectangle over it, which looks very similar to the resistor. Don't make this mistake. But the line going through the resistor, going through the fuse, represents that when the current gets really high, it becomes hot and can either melt when there's too much current. So I want you guys to stop and choose whether it's A, B or C. If a high amount of current passes through, will the wire A, B or C? Okay, as tempting as A sounds, it's actually B, because it doesn't specify here that there is a lot of current. If there's a lot of current, if there's too much current, then it will melt and break the circuit. So if you've ever heard that expression of, oh, he's going to blow his fuse, it comes from this idea that when it gets too hot, the circuit breaks. But because the current passing through it is only a high amount, we're not sure if it melts or becomes hotter. But it's definitely not C, because something does happen. Okay, now we're going to move on to this whole idea of recapping. So here's a cell, here's what a cell looks like, and here's what a battery looks like. Note that the battery is just a sum of loads of cells, so that's what this little dot thing means. It's like etc. sort of thing, added on cells. Okay, now as I said before, we're going to go back to the idea of thermistors. What's important about a thermistor is that at a high resistance, there's going to be a low temperature. So if you say that Y is the resistance and X is the temperature, if Y increases, X is going to decrease. And if X increases, Y is going to decrease. So this is how they are related. I want you to stop the video and try and answer this question. Will more or less current flow at a high temperature? Okay, hopefully you've unpaused the video and noticed that indeed more current will flow at a high temperature. If not, let me know what you're struggling with. Now we're going to move on to the LDR, a light dependent resistor. And this is the same thing as a resistor, but as the resistance decreases, light intensity increases. So for dark, low light, the resistance will be high. Little current is going to flow. But for bright, high light, resistance will be low, making more current flow. Hopefully that makes sense. If not, let me know. You'll be given a sheet like this to sort of scribble on and circle what you don't understand or circle which one here. But yeah, thank you for watching the video. Bye guys.